Hello students, today we will see about the applications of the first law of thermodynamics and as well as the what is reversible process and irreversible process. This is SEM 3 and unit 3 we have. So, we will talk about applications of the first law of thermodynamics, then we will talk about reversible process and as well as the irreversible process. So, first we will see the application of the first law of thermodynamics, that is in isothermal process, how the first law of thermodynamics will be there, we will see here. So, isothermal process means a process in which there is no change in temperature, that means the temperature will remains constant throughout the system, then we will be calling it as a isothermal process we are going to be called here. So, as the temperature remains constant here, the change in temperature, that is dt is equals to 0 here. So, as dt is equals to 0, hence there is no change in temperature, as we know that the first law of thermodynamics is dq is equals to du plus dw. So, as there is no change in temperature in this, the change in internal energy also 0. So, in the case of the isothermal process, when the temperature remains constant, the change in temperature is equals to 0. As the change in temperature is equals to 0, the change in its internal energy is also 0, which we call it as a du is equals to 0. So, as we know that the first law of thermodynamics is dq is equals to du plus dw we have. So, in this isothermal process, du is equals to 0 as the temperature remains constant. So, the first law of thermodynamics becomes as a dq is equals to dw it is going to be have. So, that means in the isothermal process, the dq is equals to dw you are going to be have here. So, hence during the isothermal expansion of the gas, work is done by the gas here, work is done by the gas which is equals to the amount of heat energy absorbed, which is equals to the amount of heat energy absorbed by it. Similarly, during the isothermal compression of the gas, during the isothermal compression of the gas, work is done on the gas which is equals to the amount of heat rejected by it. So, here by using the this isothermal process, in this case as we know that dt is equals to 0, that is change in temperature is equals to 0, therefore du is also equals to 0, that is there is a change in internal energy equals to 0, therefore the first law of thermodynamics becomes as a dq is equals to dw. That means the amount of energy whichever it is applied will be utilized in order to doing work here. So, if you take here during the isothermal expansion of the gas, during the isothermal expansion of the gas, work is done by the gas which is equals to the amount of heat absorbed by it. So, during the isothermal process, that is isothermal expansion of the gas, work is done by the gas which is equals to the amount of heat absorbed by it. And also similarly, during the isothermal compression of the gas, work is done on the gas, and the heat rejected by it, that is equals to the amount of heat rejected by it. So, that is the isothermal process in the case of the first law of thermodynamics. So, next we will move to another process, so which is a adiabatic process. So, as we know that in a adiabatic process, the heat remains constant. So, during the adiabatic process, in this the heat remains constant, there will be no exchange of the heat will takes place from the system to the surroundings or surrounding to the system. That means the change in its heat will be equals to 0, that is in this case dq is equals to 0 we have. In the case of the adiabatic process, dq is equals to 0. Therefore, we know that the first law of thermodynamics is dq is equals to dw we have. The first law of thermodynamics is dq is equals to dw. Now, this first law of thermodynamics becomes as 0 is equals to du plus dw, because in this dq is equals to 0. So, therefore, du plus dw is equals to 0 we have. Otherwise, we can write this as du is equals to minus dw we can write for adiabatic process. So, in an adiabatic process, as we know that there is no heat exchange from the system to the surroundings or from the surrounding to the system will takes place. So, therefore, the change in its heat energy will be equals to 0, that we can write it as a dq is equals to 0 we can write. So, as we know that first law of thermodynamics is equals to mathematical equation, we can write it as a dq is equals to dw, dq is equals to du plus dw we can write here. As we know that in the case of the adiabatic process, the heat exchange will be equals to 0, that is dq is equals to 0. Therefore, we can write the first law of thermodynamics for adiabatic process as du is equals to minus dw here for this adiabatic process. That means, during this adiabatic compression of the gas, work is done on the gas which is negative, and the internal energy increases by an amount which is equals to the work done on the gas. Okay. So, during an adiabatic compression of the gas, work is done on the gas which we call it as a negative here, and the internal energy increases by an amount which is equals to the work done on the gas. This is about the adiabatic compression of the gas. Suppose during the adiabatic expansion of the gas, okay, during the adiabatic expansion of the gas, work is done by the gas which is positive, the work is done by the gas which is positive, hence internal energy decreases by an amount which is equals to the work done by the gas. So, that is about the first law of thermodynamics in the adiabatic process. So, in this case adiabatic process, we can write the first law of thermodynamics as du is equals to minus dw we can write here. So, next we will move to another application of the first law of thermodynamics, which is a isochoric process here. So, we know that if it is an isochoric process, in an isochoric process is one in which the volume remains constant. The volume remains constant throughout this process here. That means, if the volume is constant, the work done by the system will be 0. The work done by the system will be 0. That means, dw is equals to, we can write it as a pdv we can write here, dw is equals to pdv we can write, which will be equals to 0. As the change in its volume is constant, we can write dw is equals to pdv, which will be equals to 0 we can write. Now, we know that the first law of thermodynamics is dq is equals to du plus dw we have. The first law of thermodynamics is dq is equals to du plus dw we have. As in the case of the isochoric process, the change in volume is equals to 0, that is the work done is equals to 0. So, in place of this work done, we can write it as equals to 0. So, therefore, the first law of thermodynamics for isochoric process, we can write it as dq is equals to du we can write. Okay. The first law of thermodynamics for isochoric process, we can write it as a dq is equals to du we can write here. So, that means, in the case of this isochoric process, the total heat supplied, otherwise the total heat supplied or rejected, which will be equals to the increase in its internal energy or decrease in its internal energy, we can say that. That is, in the case of the isochoric process, for first law of thermodynamic process, the total amount of heat supplied or rejected to the system will be equals to the increase in its internal energy of the system or decrease in its internal energy of the system. dq is equals to du you have. So, this is the first law of thermodynamics in case of the isochoric process we have. Next, we have another process which we call it as a cyclic process. Now, we apply the first law of thermodynamics for a cyclic process. So, in a case of the cyclic process, the system returns to its initial state, the change in its internal energy must be 0. That means, whenever the system is moving from initial state to final state and coming back to its original initial state, in this case the change in internal energy will be equals to 0 in the case of the cyclic process. So, as the change in internal energy is equals to 0, that is nothing but du is equals to 0, as we know that the first law of thermodynamics is dq is equals to du plus dw we have. So, as in the case of the cyclic process, we said that du value is equals to 0. Here, if you substitute du is equals to 0, we can get dq is equals to dw. Here we are going to be get here in the case of the cyclic process. So, in a cyclic process, when a system which is taken from its initial position to final position and again coming back to initial position, the change in internal energy will be 0. So, therefore, we can write for a cyclic process first law of thermodynamics as dq is equals to dw, we can write here. So, in this complete cycle of process, the heat whichever given or the heat which is taken from a system which will be equals to the work done by the system or on the system. So, the whatever may be the heat whichever we supplied to the system or heat taken for the system will be equals to the amount of work done on the system or by the system. That is the cyclic process for first law of thermodynamics. Next, we will move to another application for the first law of thermodynamics, which is a isobaric process. So, which is a isobaric process here. So, in the case of the isobaric process is taking place, in this the gas does work at constant pressure. That means, in the case of the isobaric process, the quantity which will remains constant is a pressure. As the pressure is constant, we can call this process as isobaric process we are going to be called. So, in the isobaric process, the pressure is going to be constant, that we have to remember here. Now, the amount of heat whichever we supplied is partly utilized in increasing its temperature and partly it is utilized in doing work. Okay. The amount of heat energy whichever we supplied to a system, the dq amount of heat energy whichever we supplied to a system, it can be utilized in order to increase its temperature and partly it is utilized in order to do work here. So, therefore, we can write the first law of thermodynamics whichever we have as dq is equals to du plus pdv. In place of du, this we can write it as a cp dt we can write, and the work done we can write it as a pdv. So, therefore, in isobaric process, the first law of thermodynamics can be written as dq is equals to cp dt plus pdv we can write. So, this is the one application of the first law of thermodynamics, which is a isobaric process here. Next, we will move to what is a reversible process and irreversible process. So, we should know what is reversible process and irreversible process here. So, if you take a reversible process or irreversible process, in our daily life, so many things will be happening which we are going to be observed, the things which are happening, like example in our daily life, the boiling of water we can see, the rusting of iron we can see, the melting of ice we can see, burning of paper we can see here. So, which we can observe in our daily life. So, in all these processes we observe that the system in consideration goes from initial state to final state, where some amount of heat is absorbed from the surroundings and some amount of work is done here by the system on the surroundings here. So, whatever may be the processes whichever we are talking about here, the boiling of water or rusting of iron or melting of ice or burning of paper. So, here some amount of heat energy is taken from the system and it has been done some work on the surroundings here. So, these processes whichever we have, so these processes, if the boiling of water, if you take an example, so the boiling of water can be done, that one process has been done. So, that may be reversed or may not be reversed, we have to see here. So, if this process whichever we have been done, so if it is reversed as it is, we can say that the process is reversible process. So, if it is not reversed, then we can say that this is a irreversible process, we can say that here. The system and the surroundings can be brought back to the original or initial state, we can say here. So, now for how many such systems, as we said that boiling of water or rusting of iron or burning of paper, whatever we have. So, all these processes which can takes place, whether they can get back to its original state or initial state or not, we have to see here. With common examples, as we have seen that rusting and fermentation, we can say that it is not get back to its original state. So, that means we cannot get back to original state. The process whichever it has happened, that will be happens, that cannot be get back to its original state. That means it is a reversible process, we can say here. So here if you take the reversible process, we will see what is reversible process here. So a thermodynamic process which is reversible here, so which is taking place from initial state to the final state here, which is taking place from initial state to final state here. So whenever it is moving from initial state to final state, it is said to be reversible, means the process is said to be reversible if the process can be turned back to such that both the system and surroundings return to their original states. Okay. So if you want to define this reversible process, a thermodynamic process from initial state to final state is said to be reversible if the process can be turned back to such that both the system and surroundings return to their original state with no other changes which can be takes place here. So actually this reversible process is idealized and does not occur naturally. That means practically the reversible process is not possible, means we can define this reversible process for ideal purpose, but in practical this reversible process is not possible. So why we define this reversible process is, in order to get the maximum efficiency for a real process, we define this reversible process here. So now conditions which we required in order to get the reversibility. What are the conditions we required in order to get the reversibility is, there must be total non-attendance of dissipative forces. There must be total non-attendance of dissipative forces. That means these forces should be absent if we want to take place this reversible process. Otherwise the conditions for reversibility, we can say that. What are those forces which should be absent? Here it is dissipative forces like friction. We have friction should be absent. That means whenever the process is occurring, the friction should be 0. There should not be any friction, and the viscosity should be absent. So in the absence of viscosity it is taking place, the process can be reversed here. And as well as the electric resistance. So electric resistance also should be absent. So if these dissipative forces like friction, viscosity, electric resistance and so on, if they are absent, then we can say that the thermodynamic process whichever is taking place, that can be reversed. The condition for reversibility is the absence of these friction forces, viscosity, electric resistance and so on. And one more condition which we required for reversible process is the direct and inverse forms must take place very slowly. That means whenever a thermodynamic process is taking place, from initial position to final position, it has to be takes place very slowly. Otherwise very slowly this process has to be taken place, then only the process can be reversed. That must be condition. And another condition for reversibility is the temperature of the system must not vary. That means throughout this thermodynamic process, the temperature should remains constant, it not vary from the environment. So these are the three conditions minimum which we required in order to get the reversible process. The first condition is the non-attendance of dissipative forces such as friction, viscosity, electric resistance. So in absence of these frictional forces, the thermodynamic process can be reversed. That is one condition which we required. And the second condition which we have is the direct and inverse forms must take place very slowly. That means the thermodynamic process must take place very slowly, then only we can reverse. That means the reversible process can be occur here. And one more condition which we have is the temperature of the system must be constant with surroundings, that means with environment, then only the reversible process can be takes place. These are the conditions for reversible process. Examples of reversible process if you take, so all isothermal and adiabatic changes are reversible when they perform in an exceptional slow manner. Means whatever may be the isothermal processes or adiabatic processes, otherwise isothermal changes or adiabatic changes, all they have to be performed in exceptionally slow manner, then these all isothermal as well as the adiabatic process can be reversed. That is one example which we have. And another example for this reversible process is when a certain sum of heat is retained by ice, it melts. In case the same sum of heat is evacuated from it, the water formed within the direct process will change over to ice. That means in the case of the conversion of the water into ice or ice into water, this is, we can take it as an example, but we have to be some case should be there here. When some certain sum of heat is retained by ice, it melts. Otherwise, in case of same sum of heat evacuates from it, then the water formed within the direct process can change into the ice. This is one example we have. One more example for this reversible process is an extremely slow extension or contraction of a spring. An extremely slow extension or contraction of a spring without setting up oscillations. This is an example of this reversible process. That is an extremely slow extension or contraction of a spring without setting up of oscillation. That is a example for a reversible process we have. And one more example is very slow evaporation or condensation. Very slow evaporation or condensation is an example of a reversible process we have. Next, we will see about the irreversible process. What is irreversible process? Here we have to see. So, we can define this irreversible process as a process in which the system and the surroundings do not return to their original condition. In the case of the reversible process, we can say that the system and the surroundings will get back to their original position or initial state. Whereas, in the case of the irreversible process, in this irreversible process, which we can define as a process in which the system and the surroundings do not retain or do not return to this their original condition once the process is initiated. That is what we call it as a irreversible process we are going to be called here. Suppose if you take an example for this irreversible process, if you have any automobile, that means if you have any vehicle, automobile engine that has travelled for a distance, that means it is moving from one place to another place. So, in order to move from here to there, it has to be burn its fuel. So, whenever it is burning its fuel, what happens means that burning of the fuel will be converting into energy which will move the automobile. That means the vehicle can be moved by burning the fuel. It can produce the energy and it can be moved to somewhere. So, in this case, once the fuel has been burned, that cannot get back to initial state. So, this is a irreversible process. That is the example of irreversible process we have. The factors due to which irreversibility of process occurs is the friction that converts the energy of the fuel to heat energy. The friction that converts the energy of the fuel to heat energy. And the second factor which will influence for the irreversible process is unrestrained expansion of the fluid prevents from regaining the original form of the fuel. Heat transfer through a finite temperature, the reverse of which is not possible as the forward process in this case is spontaneous. That means here as it is a reversible process because the process is taking place very spontaneously. So, that is the reason why it is a irreversible process. So, irreversible process will take place spontaneously. And another factor due to which the irreversibility of a process occurs is mixing of two different substances that cannot be separated, as the intermixing process is again spontaneous in nature. the reverse of which is not feasible. That means mixing of two different substances that can be happen very spontaneously and that cannot get back. So, this process this is the factor due to which the irreversibility of a process occurs here. So, examples of irreversible process like cooking a gas, leakage from a gas cylinder in the kitchen diffuses to the entire room. So, the diffusion process will not spontaneously reverse and bring back the gas back to the cylinder. So, this is an example of a irreversible process. And one more example of the irreversible process is the stirring of a liquid which is in thermal contact with the reservoir will convert work into heat. Whenever we stir the liquid which is in thermal contact with the reservoir will convert into work into heat here. So, increasing internal energy of the reservoir will takes place here. So, the process cannot be reversed here. And one more example for this irreversible process is Joule-Thomson effect. So, Joule-Thomson effect is a irreversible process because on reversing the flow of a gas similar cooling or heating effect is not observed. So, few other examples for irreversible process is spontaneous chemical reactions, friction, diffusion of gas, these are example for irreversible process. So, if you compare these reversible process and irreversible process, so the reversible process occurs infinitesimally slowly. That means whenever the reversible process occurs, that will occur very slowly. Reversible process is very slow. Whereas, if you take the irreversible process, the irreversible process is spontaneous or it is a rapid one which we have. And coming to the another comparison between the reversible and irreversible processes, the equilibrium is not disturbed in the case of the reversible process, whereas in the case of the irreversible process, equilibrium may be altered and may attain only after process completion in the case of the irreversible process. And one more comparison is, in the case of the reversible process, work done is maximum, the work done is maximum, and in the case of the irreversible process, work done is not maximum, work done is not maximum in the case of the irreversible process. And this reversible process, if you take, it can be easily reversed, means if the thermodynamic process is moving from initial state to final state, so again it can be get back to final state to initial state or original state. So, can be easily reversed, whereas in the case of the irreversible process cannot be reversed. So, irreversible process cannot be reversed. And another comparison which we have is, it can be made to proceed in the forward and backward direction. The reversible process can be made to proceed in the forward and reverse, that means backward direction, whereas irreversible process can occur in only one direction. So, this is about the comparison of the irreversible and reversible process which we have.